So today I am going to talk about the scattering matrix, and it's a very important in particle physics or the problems of scattering. So if a system is in state system in state say it is psi t I, it is the state of the system, then probability of finding the state B is given by CBT at smart square, right? So it is the probability of finding it. Also, another thing that this corresponds to interaction picture, and another thing which I want to recall here, that psi t as it corresponds to Schrodinger picture, and for initial time, say it is the initial time, so this can be represented as t naught, right, where this a represents the initial state, right? So initially particle state of the particle is a, state of the particle is given by a, right? It is initial state and it is represented by this wave function. So this we have to keep in mind, and we will use this idea later on. So, and here this CBT is given as, this CBT is given by psi t I, right? So let us call it as equation number 1. So let us assume that psi t I is generated from psi t naught I when operated with a linear unitary operator. That means psi t I is generated when psi t naught I is operated with this operator, right? So let us call it as equation number 2. Also, ut naught t is again identity operator. So let us now recall interaction picture. As we have studied in the interaction picture, at d upon dt of psi t I is equal to HIT. This is equation number 3. Now using equation 2 in equation number 3, using 2 and 3, 3, what we are getting, if I put it here, then I can express it as iota d upon dt. It is u t t naught psi t I must be equal to h I t u t t naught psi t naught I, right? So it is t naught will be here, and this can be written as I d u t t naught, just simplified it, t t psi t naught I is equal to h I t u t naught t psi t naught I, and this leads to the equation that leads to I du over dt naught over dt must be equal to h I t u t t naught, right? So this is the equation which we are getting from here, and let us call it as equation number 5. And here means from this equation, let me rewrite down equation number 5 again, is equal to h I t u t t naught here u t t naught depends only on the, it is suggested by this equation that it depends only on the structure of physical system, and not on the choice of, and not on the choice of the initial state, right? And initial state is represented by this one, right? So now consider psi t I, it can be represented as u t t naught psi t naught I and if in place of t naught I will put t prime, means using a dummy variable, then this equation will also represents the same thing, means these two are looks identical, right? This is just suggested by this point, and let us now choose in the similarly psi t naught, sorry, psi t prime, it is equal to u t prime t naught. According to this part, I am writing this as it is psi t naught, right? And Now psi t can be written like this: psi t I, it is represented as u t t prime, this one psi t prime I, and if I put this value of psi t prime from here to here, then it is equal to u t t prime t naught psi t naught I, right? Now what does it mean? It means that u t t prime must be equal to u t t naught and u t naught t prime t naught, right? Therefore as we know that u t naught t naught is equal to I, it's equal to I. So that means just a minute. Now u t naught, sorry, u, just a minute, u t t naught, from here we can write down it like this: u t, and the prime is replaced by t naught, and u t naught t naught, right? Sorry, yeah, just a minute. Since we know that u t naught is equal to I, so okay, yeah, let me do one thing. As we know that okay, this is equal to this one, its value will be equal to this one, and if I compare this part and this part, then I can write down, yeah, I'm here a little bit wrong. Yeah. So from here I can write down it as this u t t naught is equal to this one. Since this is equal to this one, so therefore if in this equation I will replace this t with t naught, then this will become t naught and this will become also as it is. So that means what do I do? This is u t naught is equal to, this t is replaced by t naught and t prime, and u t prime and t naught. So now if I use dummy variable, means t prime is replaced by t, then I can write down t naught is equal to u t naught t u t t naught, right? We can write down it in this way. But this is equal to I operator, as we have defined earlier, is this way. So therefore I can express this u t naught t naught is equal to I, or it is equal to t naught t and u t t naught, right? That's what I am getting here. Let us call it as equation number 6, or this may also be written as like this, because this leads to the fact that u t naught t is equal to u inverse t t naught. This also leads to the equation number 6. So both the equation represents the one and same thing. So that means u satisfies group properties. Group properties, we have studied it in the mathematical physics group, in the group theory. So now again consider the equation. Equation 5. So according to this equation, I du t t naught upon dt is equal to h I t u t t naught, and if I multiply both sides by minus iota, then it will become minus iota square du t t naught over dt is equal to minus iota h I t u t t naught. So minus iota square is minus 1, so that makes it positive. So that means du t t naught over dt is equal to minus h I t u t and t naught, right? So the solution of this equation, can be written as u t. It's like a simple taking integral on both sides, then this leads to this type of solution. It is 1 minus iota t naught to t h I t 1 and u t1 t naught dt1. That's what I am getting here. Let us call it as equation number 7, and this equation can be solved iteratively. So for this, let us do as follows: u t t naught is equal to 1 minus iota integral t naught to t. Here h, let me rewrite down it as dt1 will be here, and h I t1, it will remain as it is. Now inside, what I will do, I will again use the same formula, right? So for this, I can write down it as 1 minus its iota, it is t naught to t1, now it's integral, and it is dt2 h I t2, and then again u t2 t naught t2 t naught. I will use this formula, and This simplifies to 1 minus iota. It is t naught to t. It is dt1. It is hi t1 plus, because minus minus will become plus, and it is minus iota square. It is minus iota square, and it is again dt2 h this multiplied with it, so it is h, not dt2, but now it is dt1 again, yeah, dt1 hi t1, and then this part it gets multiplied here. It is t naught to t, and it is t naught to t1, and it is dt2 hi t2, and then again ut2 t naught, right? So that's what I am getting here. Even I can again use this formula here, and so on. We keep on doing this, and I just write down it simply as, so the final result which I am getting is like this, and so on. So let me write down that result here. So therefore it is u t naught, it is equal to 1 minus iota integral t naught to t, it is dt1 hi t1 plus minus iota square, it is t naught to t, it is dt1 hi t1, and it is t naught to t1, it is dt2 hi t2 plus, and so on. And let me call this as equation number 1. So this equation is the basis of perturbation theory. It's like a perturbation theory. So this equation is basis of perturbation theory. It's basis of the perturbation theory. So now at t is equal to t naught, and this approaches to minus infinity, the system is known to be, the system is known to be in the eigenstate A of h naught. So now CBT, it can be written as B psi t I, as we have defined it earlier, and using equation 2 we can write down this as B, it is ut t naught psi t naught I, and for the limit t naught approaches to minus infinity, I can write down it as B ut t naught psi t naught I. Then it is interaction picture, so let us modify it using Schrodinger picture here, incorporating or bringing here Schrodinger picture. So it is u t naught e raised to power iota h naught t naught and psi t naught I. Here I have used the idea that was discussed in that lecture, that psi t I is equal to e raised to power iota h naught t psi t s. I have used this concept here. So if I use this, then this equation will be like this. Let us now recall that as I have defined in the beginning of the lecture, that psi t naught s, it can be written as a t naught, and or it can be written as a e raised to power minus iota e a and t naught. So if I put this value here, then CBT can be written as, or equation number 10 can be written as, that CBT is equal to limit t naught approaches to minus infinity, it is b, it's u t t naught e raised to power iota h naught t naught a e raised to power minus iota e a t naught. So Ea corresponds to eigenvalue corresponding to this Hamiltonian h naught, and using t naught equal to minus infinity, this will become, the CBT is equal to b u t minus infinity, and it is a, right? So this is equation number 11. That's what we are doing here now. So now for large t, now for large value of t, that is t approaches to infinity, that means limit t approaches to infinity, CBT, it can be written as limit t approaches to infinity, it is b u t infinity, negative sign will be here, and it is a. So this can be written as b u infinity to minus infinity, and it is a. So here the operator s is equal to, let us define a operator s, and it is equal to u infinity to minus infinity and it must having matrix elements defined as that SBA, right? So that means I can write down it as this BSA, and is called, means this operator is called, it is called S matrix, right? And this S matrix is unitary. Another thing is that S matrix is unitary. That's a very important thing which we have to keep in mind, and let us try to prove it. Let us prove it. So according to law of conservation of probability, according to law of conservation of probability, that summation b CB infinity square is equal to 1. So if we expand it, then it can be written as B S A SA, its complex conjugate, and summation over B, it must be equal to 1. So it modifies to A S dagger B, and here it is equal to 1. Over here I will apply the completeness theorem. And what is the completeness theorem? Let me write down that. So that means summation over B, it is always equal to 1. So using this I can write down this as simply that A S dagger S A is equal to 1. But so this, it means that S dagger S is equal to identity operator. So this is the condition for an operator to be unitary. So this means that S is unitary operator, right? So hence we have proved that S matrix is a unitary operator. So that's all for this lecture.